Hey guys, one more problem that we're going to review together, and then I'll let you try to work on the rest of the review sheet on your own. I will be posting an answer key, so you will have all the answers available to you, but I wanted you to attempt some of these on your own as well. So we're going to go over number 6 on the stoichiometry review sheet. This one kind of encompasses everything that you've been asked to do and that you've been taught over the last few weeks. So we will go through this one step by step. There are 5 parts to this problem, and we will take it slowly, one at a time. So it says silver nitrate reacts with ferric chloride, FeCl3, to give silver chloride and ferric nitrate. All of the formulas are given to you in this problem, so there's nothing you have to figure out there. In a particular experiment, it was planned to mix a solution containing 25 grams of silver nitrate with another solution containing 45 grams of iron chloride or ferric chloride. Write the chemical equation for the reaction. So I've already done that for you and balanced it. Remember, that is the most important step. You want to always do that first. Make sure you don't forget to balance your equation, because if you don't balance your equation, then it's going to throw off everything else that you do after that in a stoichiometry problem. The next thing it asks is, which reactant is the limiting reactant? So we know that we have, 25 grams of silver nitrate, and we know that we have 45 grams of iron chloride. Okay, so I listed those there so that we could see them. But what we're going to do is figure out which of these is our limiting reactant. Now, if you don't have a periodic table handy, you are going to need one. So pause this video and go grab your periodic table. If you're all ready to go, we're going to get started. So what we're going to do is 2 calculations. We're going to start with both of these given amounts, 25 grams of silver nitrate and 45 grams of iron chloride. And we're going to convert both of those to the same product. Now I'm going to quickly glance through the rest of this and see if maybe one product is a better choice than the other. So the next part of the problem asks, what is the maximum number of moles of silver chloride that could be obtained? And what is the maximum number of grams? So we want to know later on in this problem how much silver chloride we're going to be forming. So I am going to convert both of these given reactants to silver chloride. That way I cut out an additional step later on. I take a little shortcut through this problem. So I'm going to convert 25 grams of silver nitrate into moles of silver chloride, and I'm going to convert the 45 grams of iron chloride into moles of silver chloride. That's what part C of this problem is asking us to find. So if we do it in part B, we're cutting out some work, making it a little bit easier on ourselves. Now, when we have grams of anything, the first step is always to convert grams to moles. Mass of substance A to moles of substance A. So we're going to do that using the molar mass, which we find on the periodic table. So if you look at your periodic tables, we're going to calculate the mass of silver nitrate. Silver is 107.87. Nitrogen is 14.01. And we have 3 oxygens, each at 16 grams per mole. So that's 48, 16 times 3. So 107.87 plus 14.01 plus 48. That looks better. The molar mass of silver nitrate is 169.88 grams per mole. So that's going to be my first step in solving this problem. I'm going to set up a molar mass where I convert my given amount of silver nitrate into moles of silver nitrate. Now we're going to take one more step, because part B, remember, is asking us to find moles of silver chloride. So we're going to be going from mass of substance A, which in this case is silver nitrate. We're going to do this again with the iron chloride, and we have now converted to moles of substance A. We're going to take one more step to get to moles of substance B, which is the silver chloride. So we're going to look back at our balanced equation for the mole ratio. Now, if you look at your balanced equation, there's 3 moles of silver nitrate in our balanced equation. So that's going to go on the bottom because we want moles of silver nitrate to cancel out. and we are converting to moles of silver chloride. There's also 3 of those in our balanced equation. So we're going to put 3 moles of that over 3 moles of the silver nitrate, and now we're going to solve. So 25 times 3 divided by 169.88 divided by 3. That gives us 0.147 moles of silver chloride. Now, we're not quite done yet. We want to find the limiting reactant. So we want to see which of our reactants is going to give us less product. We know how much product the silver nitrate is going to give us, 0.147 moles of silver chloride. So let's take a look at the iron chloride and see how many moles of silver chloride that will give us. So starting with 45 grams of iron chloride, we're going to put that over 1. And the first step then is going to be to find the molar mass of iron chloride in order to calculate moles of iron chloride. So we want to go to our periodic tables. The mass of iron, 55.85, plus 3 chlorines. Now each chlorine is 35.45, so we want 3 of those. So the total is going to be 162.2 grams of FeCl3 on the bottom and 1 mole of FeCl3 on the top. Okay, if you're following along, this is the bottom calculation. We started with the 45 grams that was given to us. This first step after that is our molar mass step that comes directly from the periodic table. One more step to convert moles of iron chloride into moles of silver chloride. So going back to your balanced equation, we have 1 mole of iron chloride in our balanced equation. That's going to go on the bottom of our next step. And we have 3 moles of silver chloride, and that's going to go on the top of our next step. So our work looks like this, and we're going to get ready to calculate our answer and compare it to the previous one. So 45 times 3 divided by 162.2 is equal to 0.832. 0.832 moles of silver chloride. So now what we want to do is look at these two values in relation to one another. Remember, the limiting reactant is always going to produce less product. So the lesser amount is the amount that's actually, or not actually, theoretically produced in this reaction. So we are going to be using the first calculation. I'm going to X out the bottom because that is a bigger number. Okay, we want to go with the smaller number. So I'm going to erase that bottom calculation because I don't want us to get confused and think that we're using that in any way. We're going to get rid of it. You guys can cross that out if you wrote it down, because I don't want you to I don't want it to confuse you. So this amount that we calculated here is the maximum number of moles of silver chloride that could be obtained. The smaller amount is always the maximum amount that you could potentially produce. So we have just answered part C, 0.147 moles of silver chloride. Okay, now going on to part D, what is the maximum number of grams of silver chloride that could be produced? Well, we already have moles, so we're going to take that one step further. 0.147 moles of AgCl over 1. And we are going to just simply convert moles into grams. We'll put 1 mole of AgCl on the bottom of our fraction here, of our conversion step, because we want that unit to cancel out with what we started with. And then we're going to calculate the molar mass of AgCl using our periodic tables. And that's going to be equal to 143.32 grams per mole. Okay, so we're going to set up our calculation to look like this, and now we're going to solve. So 0.147 times the 143.32 is equal to 21.1 grams of AgCl could potentially be produced in this calculation. Okay, so now that was part D. And then it says in part E, how many grams of the reactant in excess will remain after the reaction is over. All right, well, we determined that silver nitrate was our limiting reactant. So we now want to figure out how much of that iron chloride is going to be left over. Okay, so I'm going to erase some of this so that we have some room to do our final calculation step here. We know the silver nitrate is our limiting reactant. We know that the limiting reactant controls everything in our calculation. It controls how much reactant or how much product is formed. It controls how much of the excess reactant is used up, and therefore how much of the excess reactant is also left over. So we always want to start our calculations with the limiting reactant. So we're gonna go back and start with 25 grams of silver nitrate. Okay, and now it doesn't really specify in the problem. Oh, yes, it does. I'm sorry. It says how many grams would be left over. Now, let's say the problem just said how much is left over. Well, you want to base what unit you decide to use on the units that are given to you. Since we're given grams of iron chloride in the problem, well, we are going to have to compare that with grams. So we're going to have to convert grams of silver nitrate into grams of iron chloride to see how much. All right, so the first step, converting grams of silver nitrate into moles. So we're going to use our molar mass. If we go back, you guys have the calculations written down already. I just erased them, so I'm just going to quickly calculate them one more time. The molar mass of silver nitrate is 169.88. So that's my first step. Then I'm going to do a mole ratio step based on the balanced equation. So 3 moles of silver nitrate is going to go on the bottom because that's the coefficient of silver nitrate. And 1 mole of iron chloride goes on top. And then one more step to convert moles of iron chloride into grams. So iron 55.85 plus 3 chlorines. 162.2 grams. Okay, so here is our work. The setup is what we were given to start with, our limiting reactant, 25 grams of silver nitrate. The next step is a molar mass step, then a mole ratio, and then another molar mass step. So if we calculate this, 25 times 162.2 divided by 169.88 divided by 3. 7.96 grams of iron chloride is used up. But that doesn't tell us how much is left over. So we want to go back to the beginning. We started with 45 grams of iron chloride. That was given to us in the problem. 45 grams of iron chloride minus the 7.96 grams that we used gives us 37.0, with rounded to 3 sig figs, grams of iron chloride remains. Okay, and that is what the problem is asking. So part E of this problem asks us how much of the excess reactant will remain. And so you want to subtract how much is used up from the given amount. All right, so that was problem number 6. If you have questions, please feel free to email me or comment on this post on Classroom, or wait until our live chat and you can ask me in real life. And I will be posting answers to the entire answer key at some point this week, but I wanted to give you guys a chance to try the problems yourself before we did that. So good luck, and let me know if you have any questions.